This is lab 2, dealing with lines of charge. Here's a table of contents for what we covered in the lab. As we see, we'll have an introduction. We'll look at the principles we used. We'll look into the procedures for the experiment. We'll observe the code used in GlowScript to model the situation, and then interpret these results, and then show the what-if scenario, and end with the conclusion with potential sources of error in the experiment. So moving into the introduction and overall purpose of this lab, it is a continuation from lab 1 with a different way of looking at the result. As shown here in the purpose and assumptions, the purpose of this lab is to continue the process from lab 1, but assuming that the tape is a line charge instead of a point charge. So we treat the floating piece of tape having an equally distributed charge across the entire length, as opposed to the point charge right down the middle from last week. And then this equal charge distributed along the entire length of the tape in this lab. And some goals was to determine the electric field of a charged piece of tape, find the charge of tape pieces by having two charged strips interacting with each other, and then write a code in GlowScript used to model the experiment and calculate the charge of the tape pieces as an evenly distributed line charge. Here are the physics principles used in this lab. As we see, the concept of polarization, which is a result of certain electromagnetic radiations, which occurs when a neutral object comes into contact with a charged object, thus causing the neutral object to be polarized through a temporary dipole. We see the other principle of opposite charges attracting and like charges repelling. And then the three main forces used were the force due to gravity, the force due to the electric field of a point charge, and the overall electric force produced by the electric field. We also see the principle of electric fields and distributed charges in the overall process to calculate them. We divide the objects into a series of point charges. We find the E field of each piece, and then summing them up to attain a net electric field, and then calculating the charge from there. We also utilize the superposition principle. The procedures for this lab were the same setup as lab 1 as shown in the illustration. We see two charged pieces of tape, one attached to two books and one hanging below it. And the hanging tape began to float above the charged tape when we brought the lower piece closer to it. Other key formulas we see is the force of gravity is m times g, mass times the gravitational constant, Fe equals E times Q, and then E equals KQ over R squared. And then a key assumption, in order for tape B to float, the force from the E field of tape A must equal the force of gravity on tape B. And given the mass was 0.00023 kilograms, we see that this force is calculated to have a magnitude of 0.00226 newtons. Now moving into the code used in GlowScript to model the experiment. As we see here in the red boxes are the changes made to the original starter code provided for the model. The first box here, we see the mass of the tape and estimated net charge on one tape were entered, the specific values used, as you see there. The second rectangle here shows the function for electric field we used from lab 0. Moving into this box, we see the changes made to the Y component for the top piece of tape and the bottom piece of tape. As we see, this was the distance of 0.0175 meters away from each other. We see here that highlights the arrow scale for the E field vector and the electric force vector. As you see the arrow scale there for each vector. Moving on to this box, we change the formulas to calculate the E force and to create the arrow for the net electric field at dq top due to the bottom tape, and to calculate the electric force vector and gravitational force vector edited to create the arrow. We see that these values down here. Interpretation of our results, as that we have our initial conditions previously mentioned, we see this R vector of 0 in the X 0.0175 in the Y and 0 in the Z. The distance between the tapes, the mass of the tape was 0.0023 kilograms, and that electric force and gravitational force the same magnitude of 0.00226 newtons. As you see here, we see the arrows for E force and gravity, the white and yellow arrows. The yellow pointing down is gravity, white is the electric force. And then you see the red and the blue segments created to highlight the line charge along the entire piece of tape. After entering this into the model, we obtained the following values. The magnitude of the electric force was 7.49506 times 10 to the negative third newtons. The gravitational force, as mentioned, was 0.00226 newtons, and the total charge of the tape was found to be 9.55608 times 10 to the negative eighth coulombs. As for the what-if scenario, what if we modeled each of our tapes as a single point charge like in the previous lab? If this was modeled as a single point, it would be less accurate and have a smaller charge due to a concentrated area, as opposed to the sum of multiple charges found in a line charge we used in lab 2. The point charge in lab 1 was this value of 8.17083 times 10 to the negative ninth, while lab 2 was 9.55608 times 10 to the negative eighth coulombs. And these estimates differ because the values are different due to the shape of the electric fields, which changes from a point charge treated like a sphere to a line of charges. And the line charge in model 2 is more accurate and closer to the actual charge, since this line charge better models the actual shape of a piece of tape. The conclusion, the distributed charge calculation is likely more accurate, and this line charge accounts for charge across the entire piece of tape, which is more accurate description of the situation. Possible sources of error in this experiment, the main one is too much contact with the tape pieces from my hand affecting the charge of each piece, and measurement errors involved in the setup of the experiment and the transfer of that data into GlowScript. As you see in the depiction here, though, we see Lab 2 shows this concept that the entire tape is charged as opposed to one single point charge in the center of the piece of tape.